this video, I want to explore the transformation of absolute value functions. So the first thing that we need to know is what is the parent function of an absolute value function. The parent function is the very minimum you need to have that function. So in this case, it's just the absolute value of x. So let's look at a couple things here that make this help us with our transformation. So first of all, I'm going to notice that my vertex is at 0, 0. So that's important. Before we get any further, let's see what happens when I plot a couple points, because I want you to be able to plot this. It's not just a pretty picture. So what I'm going to do is we're going to create a table, and I'm going to show you that if we put in some values for x, it is actually going to graph on this absolute value function. So I'm going to change my y1 to be the absolute value of x1, and the reason it's x1 is because x1 is my input in my table. So if I put in -3, my absolute value is 3. When I put in -2, my absolute value is 2. When I put in -1, my absolute value is 1. If I put in 0, absolute value is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. And absolute value of 3 is 3. So what I want to also point out as we look at these points, we need to realize that's where my parent function starts at 0, 0. That's the vertex. So we're going to look at where the vertex goes to our new function as we move and transform the function. The other thing I want you to notice is on the right side, there's just a line so we can look at the slope. I go up 1, right 1, up 1, right 1, up 1, right 1. So on the right, I have a slope of 1. That will become important later on. So what I'm going to do here is I'm going to put in the point 0, 0, which you should graph, and I'm going to label that vertex, and that's at 0, 0. So we can see that there. We're going to compare everything to that vertex. So instead of writing f at x, I'm just going to say y. So if I put y equals the absolute value of x, I can see that it graphed right over the parent function. It's the exact same as the one up here. But I want to do some transformations. Think of your absolute value as grouping. So I'm going to do a +3 inside the absolute value, which is a x thing, because x is what's inside. So notice what happened now to my absolute value function. My vertex is now -3, 0. So clearly my vertex moved from 0, 0 to -3, 0. That entire function moved 3 units to the right. If I'm going to, 3 units to the left. So notice that it's opposite of what I see here. This is a +3, but it moved left. So it moved left 3 units. I also want to note that if I go up 1, right 1, up 1, right 1, up 1, right 1, I'm hitting all those lattice points, so my slope is the same. So the only thing that's changed is that my function moved 3 units to the left. Let's see what happens here. Let's make this, instead of a +3, if I make it a -3, we can see my vertex moved 3 to the right. So that's what happens inside my x in the absolute value. If it's grouped with the x, it does x things. X moves left and right. So now let's see what happens outside. So let's put a +3. So notice that +3 is outside of the absolute value function. And notice my new function went up. So my vertex here was 0, 0. My new vertex is 0, 3. So the entire function moved up 3 units. Every point on that new function went up 3. The 3 is on the outside. The outside is y things, okay? So let's go ahead and see what happens if I make that a minus 3. If I make that a minus 3, notice that my vertex is now moved down. So my vertex, the outside, is telling me my y value of my vertex, and the inside is telling you the x value of my vertex. So let's do one more example with both. So let's do a shift. Let's do left 2, which means I'm going to put in plus 2, and you can see it moved left 2. But let's make it down 4. So I'm on the outside of the absolute value now. I'm going to put a minus 4. So we can see my new vertex, my x is at negative 2, and my y is at negative 4. If we look inside here, the opposite of 2 is negative 2, and the same is negative 4 for my up and down. Okay, so that's kind of important to remember. So that is what happens when we can shift it to the left and then down, or we can shift it to the right and then up, or any combination thereof. Okay, so let's look at another transformation. So I'm going to put this back to the parent function, which is just the absolute value of x. What happens if I put a number like 2 in the front? Well, we can see that my function got narrower from the parent. Remember, this is my parent down here. Nothing's changed there. But notice that it's gotten steeper. My slope now is up to right 1, up to right 1, up to right 1, up to right 1. So this 2 in the front is acting like the slope. So let's see what happens if I make it 4. Well, it got steeper still. Notice I have to go up 4, right 1, up 4, right 1. So that made it even steeper. But what happens if I make that a negative 4? Notice how I now have a reflection. My absolute value flipped upside down because I want a negative slope. Remember, I'm only going to look at the right side, and the left side will be a mirror image. So here I go down 4, right 1. I have a place right there. Down 4, right 1. I have another point right there. So that's showing me that if it's negative, my absolute value is upside down. So the same thing would happen if I just put a negative in front. Notice that's the same as negative 1. Down 1, right 1, down 1, right 1, down 1, right 1. Okay, so we did the inside, we did the outside, we did a multiple in front, but what happens if that multiple is not an integer? It's not 2, it's not negative 4, it's something like a fraction between 0 and 1. So a fraction between 0 and 1, let's do 1/3. So I put in 1/3. Notice that my new function is gotten squashed. It's been pressed down. So think about this point has been pressed down. So that makes this what's called a compression. So let's look at that slope for 1/3 again on the right side. I want to go from here to here. So I'm going to go up 1 and right 3. Up 1, right 3. That is a slope of 1/3. And again, if I put a negative in front, it has reflected. We say it reflected over the x-axis because it's going upside down. But our slope is down 1, right 3. Down 1, right 3. Again, we are only looking on the slope at the right, and we do a mirror image on the left. Okay, let's do one more thing. Let's put all that together. So let's say I want to move right 5 and I want to go up 6. So you can see my vertex is now 5, 6. So I'm going to put that, see, there's my vertex. My vertex is now 5, 6. But let's say I want to reflect it over the x-axis. So I'm going to make that negative. Okay. And it's a -1 slope because I'm going down 1, right 1, down 1, right 1. But let's say I want to make it skinny. So if I want to make it skinny, it has to be a number bigger than 1. So let's be creative. Let's put 3 halves. 3 halves is bigger than 1. That's 1.5. So it's kind of hard to see that this got skinnier, but it did. And I'll show you again. So let me get rid of that fraction. That's -1. So if I put in 3 halves, it got skinnier. It went, instead of down 1, right 1, down 1, right 1, it went down 3, right 2, down 3, right 2. So you can see there are a whole lot of different combinations I can do with transformations. So they can either move left, right, up, down. They can get skinny. They can get fat. And they can go upside down.